second part, we're talking about the relative strength of acids and bases. You remember in Bronsted-Lowry theory, we talked about conjugate acid-base pairs. So if you consider this as the base and this as the acid, and this is a conjugate pair, I'll write the conjugate here because I need the space here. All right, so there is a balance between them. If the acid is strong, its conjugate base is weak, and if the acid is weak, the conjugate base is strong. So whenever one of them is strong, the other one is weak. Whenever one of them is weak, the other one is strong. You have a table in your PowerPoint slides about the relative strengths of acids and bases, and you will see like the strongest acid is HClO4, and then H2SO4, then HI, and then HBr, and so on. And you might ask this question: how do you determine, besides having the measurements and experiments, how would you know that why HClO4 is the strongest? So let's, before answering that question, work on one question you have on your PowerPoint slide number 24. Let's work on this. It says formic acid. Formic acid is an organic acid. This formula is a strong acid, is stronger than acetic acid. Acetic acid is the acid in the vinegar. So this is formic, and this is acidic. And those of you who need to take organic chemistry, you will learn how to name each of these and what are the structures. So no worries about the structures and anything about organic chemistry at this point. So the question is saying that formic acid is stronger than acetic acid. Which is the stronger base? So formic acid, let me use a bigger sign to show it's stronger than acetic acid. Which one is stronger? CHO2, sorry. CHO2, what is it with a negative charge? That's the conjugate base of formic acid, right? Formate, it's called formate ion. And C2H3O2 with a negative charge is the acetate ion. Acetate ion. So we are going to determine which one is stronger. Formic acid is stronger than acetic acid. Now, which one is stronger, formate ion or acetate ion? Now, what we just said should be applied. If an acid is stronger, then its conjugate ion is what? Weaker. So formate ion is weaker than acetate ion. Now, going back to answering our question, how do we determine these acids are the strongest acids? Do you remember from Chem 1 that we have two types of acids? Binary acids, like H2S, like HCl, like HBr, like HF, HI, right? These are binary acids. Hydrogen plus a monatomic anion. And we also have oxyacids or oxoacids. Let's call it oxoacids. Like what? like HCl4, like H2, SO4, and so on. The acids with oxygen, acids with polyatomic anions. So let's talk about the strength of binary acids first. If you have a binary acid composed of hydrogen and a halogen, X can be fluorine, chlorine, bromine, or iodine. As the size of X increases, which is from top to bottom in a group, fluorine, chlorine, bromine, and iodine. If this is the size, this is chlorine, this is bromine, and this is iodine. All right? So by increasing the size, the bond between hydrogen and the halogen is going to become weaker and weaker and weaker. So hydrogen is released better and faster. So it's going to be from the weakest to the strongest acid. When we say a strong acid, means they can release their hydrogen ion better. So by increasing the size down a group, the acidic strength increases. But when we're going across a period from right to left, the acidic strength increases also. Like if you're going to compare H2S and HCl. Let's say this is H2S here, and this is HCl here. So from left to right, what happens? Electronegativity of the nonmetal increases. When electronegativity increases, it pulls the shared electrons in covalent bond more strongly towards itself, and the hydrogen will be released faster. So from left to right, electronegativity increases, and we're going towards stronger acids. So now, if you want to compare, you're working on slide number 28. If we are working on comparison, let's say we're going to compare HF and HCl. What should we pay attention to? These two are in the same group, so we just determine which one is lower down the group. That would have a larger size and it will release the hydrogen faster. So HCl is stronger. Between H2O and H2S, again, we are comparing between the two elements in the same group, oxygen and sulfur. Which one is larger in the lower down the group? H2S. So H2S is a stronger acid. And between HCl and H2S, we just said that, we just mentioned it. HCl is more towards right, is more chlorine is more electronegative, and the hydrogen is going to be released faster. So this is how you justify the strength of the acid for binary acids. The reason for oxoacids is different that I'm going to talk about them right now. So erase the binary acids. About oxoacids, let me go with the same examples you have. Let's compare HClO, HClO2, HClO3, and HClO4. All the oxoacids with chlorine, with hypochlorite ion. This, if you remember from Chem 1, it was hypochlorous acid, chlorous acid, chlorite acid, and chloric acid and perchloric acid. So the name doesn't matter, but maybe rings a bell. Hypochlorous, chlorous acid, chloric acid, and perchloric acid. So what is the difference? You see each of them has one hydrogen, one chlorine, so the only difference is the number of oxygen atoms, right? The structure is like you have one acidic hydrogen. Acidic hydrogen is the one which is released, HClO. Then you have the direction of electrons. Chlorine is more electronegative than oxygen, right? Then for HClO2, you have, again, this is the same for all of them, OH. And then you have another oxygen here. Then you will have it towards, now two electronegative elements are pooling, you see? Both here just chlorine, here chlorine and one more oxygen, or let's say two oxygens here and one oxygen here. But for HClO3 you have right? Or let's not put the, so you see 3 oxygens and 1 chlorine are pulling. The number of electronegative elements is increasing by increasing the number of oxygens. And now all of these elements are pulling the electrons towards themselves. So you have 1 chlorine and 4 oxygens. So you can imagine how loose the bond will be and how fast the hydrogen will be released comparing to when you have less number of oxygens. So by increasing the number of electronegative atoms, you can expect the acidic strength to be more. So the strongest is HClO4. But what if you are comparing the two acids like this, HClO and HBRO, even without drawing the structure, that is really not necessary. What is the similarity between these two? Each of them has 1 hydrogen and 1 oxygen. What is the difference is their central atom, right? So the difference between central atom is their electronegativity, right? Which one is more electronegative? Chlorine, right? Down a group, electronegativity decreases. So because chlorine is more electronegative, it's going to pull the electrons away from hydrogen, so it will be stronger. So for comparison, you need to look for the differences. Now, the acid strength of a polyprotic acid and their anions decrease with increasing negative charge. That's the last thing for comparing the acidic strength of acids that you need to know. So let's say if you are going to compare H2CO3 and HCO3 with a negative charge, the acidic strength of polyprotic acids. Polyprotic acid, what is a polyprotic acid? Is an acid that has more than 1 acidic hydrogen. So polyprotic acid. So far, each of the acids that we compared with each other, they just had 1 hydrogen. But what if your acid has more than 1 hydrogen? So a polyprotic acid has more than 1 acidic hydrogen. What is an acidic hydrogen? Is the hydrogen which is released. So between these two, if you want to compare, H2CO3 is a stronger. So basically, by losing the hydrogen, by losing the proton, acidic strength decreases. So if it loses one more hydrogen, so it's the last one is even weaker. So the first one is like looks like the fresh one, more fresh one, so it has more energy, but is a stronger, like H2SO4 and HSO4. Which one? Again, the one with more hydrogen, less negative charge. And if it loses one more hydrogen, what happens? This becomes even less strong. Between H3PO4 and H2PO4 with the negative charge, the first one is the stronger. If it keeps losing the hydrogens, HPO4 now with a -2 charge, so it's even weaker again. And finally, you got all the energy from this acid by getting all of its hydrogens. So it's even, the anion is going to be even weaker because it has a maximum negative charge on it. So basically, whenever we want to determine the direction of the reactions always go from the stronger towards the weaker. Stronger acids to the weaker acids, or stronger bases to the weaker bases. Like this example that you have on your PowerPoint slides. Slide number 34. Slide number 34 is giving you this equation. HCN plus HSO3 with a negative charge. CN plus H2SO3. You probably need to have the acidic strength, and then in this case the table will be given. So this is a stronger because this is an acid here. Let's determine the acids first. I should have told you that. Let's determining the acids first. HCN and CN, it has donated the protons, so that's the acid. And on the other side, H2SO4 has donated the hydrogen, so this is the acid. Which one is a stronger? H2SO4 is a stronger than HCN according to that table that you have, the acidic strength, and because it has 4 oxygens. So when it's a stronger, means that the direction is more towards the left side, is favored towards the left side, favored. It doesn't mean that it's all towards left, but most of the reaction is towards left. You will have more of these two than this. Okay. In the last part of this chapter, which I'm going to talk about in the next video, we will work on some of the calculations on how to determine the scale of acidic strength, the pH, pOH, and the related equations and calculations.